Hello everyone, here are videos for civil engineering. Welcome to the channel Amazing Civil Engineering Studies. Here we have different videos on all topic of civil engineering. Please subscribe and press bell icon, like and share as many as possible. Part 2. Geotechnical Engineering, Soil, Question and Answer. 1. State the assumptions in the derivation of Terzaghi's consolidation equation. The soil mass is homogeneous. The void spaces are completely filled with water. The soil solids and water are incompressible. Darcy's law is valid. The seepage flow and deformation are in one-dimensional direction. Strains are small. The permeability is constant over the range of effective stresses. There is a pressure-void ratio relationship, i.e., the coefficient of compressibility is constant. The time lapse in consolidation is entirely due to low permeability of soil. 2. Define compressibility. When a compressive load is applied to soil mass, a decrease in its volume takes place. The decrease in the volume of soil mass under stress is known as compression, and the property of soil mass pertaining to its susceptibility to decrease in volume under pressure is known as compressibility. 3. Define coefficient of compressibility. The coefficient of compressibility is defined as the decrease in void ratio per unit increase of pressure. 4. What do you mean by optimum moisture content? The dry density goes on increasing as the water content is increased, till maximum density is reached. The water content corresponding to the maximum density is called the optimum moisture content W. 0. 5. Define hydrodynamic lag. The delay caused in consolidation by the slow drainage of water out of a saturated soil mass is called hydrodynamic lag. 6. What is frost heave? Water migrates upward from the water table to the capillary fringe. When the atmospheric temperature falls to the freezing point and the ice is formed, this results in an increase in the volume of the soil. This is known as frost heave. 7. List the various factors influencing compaction of soil. The various factors which affect the compacted density are as follows. Addition of admixtures. Amount and type of compaction. Method of compaction. Type of soil. Water content. 8. What is consolidation? In a saturate soil mass having its voids filled with incompressible water, decrease in volume or compression can take place when water is expelled out from the voids. Such a compression resulting from a long-term static load and the consequent escape of pore water is termed as consolidation. 9. Define the term relative compaction. Degree of compaction is also sometimes expressed in terms of an index called relative compaction, R. C. defined as the ratio of dry density to the maximum dry density from compaction test, equals / State any two assumptions made in Terzaghi's theory of one-dimensional consolidation. Compression and flow are one-dimensional. Darcy's law is valid. The soil grains and water are both incompressible. The soil is completely saturated. The soil is homogeneous. What is the use of consolidation data? The consolidation test data are then used to determine the following. Coefficient of consolidation, coefficient of permeability, void ratio and coefficient of volume change. Differentiate compaction and consolidation. S.No. Compaction, consolidation. 1. Compaction is the process by which soil particles are packed more closely together by mechanical means. Consolidation is the process by which soil particles are packed more closely together under the application of static loading. 2. It is achieved through reduction of air voids. It is achieved through gradual drainage of water from soil pores. 3. It is a rapid process. It is a gradual process. In some soils it takes many years. 4. It is an artificial process. It is an natural process. 5. Proper compaction of soil is achieved at optimum moisture content. Consolidation is strictly applicable for saturated or nearly saturated clays or soils with low permeability. What do you mean by initial consolidation? When a load is applied to a partially saturated soil, a decrease in volume occurs due to expulsion and compression of air in the voids. A small decrease in volume occurs due to compression of solid particles. The reduction in volume of the soil just after the application of the load is known as initial consolidation or initial compression. For saturated soils, the initial consolidation is mainly due to compression of solid particles. What are the factors influenced by the compressibility of the clay? The compressibility of clays may also be caused by three factors are: the expulsion of double-layer water from between the grains, slipping of the particles to new positions of greater density, bending of the particles as elastic sheets. Define hydrodynamic pressure. The pressure that builds up in pore water due to load increment on the soil is termed as excess pore pressure or excess hydrostatic pressure or hydrodynamic pressure. Define primary consolidation. The reduction in volume of soil which is due principally to a squeezing out of water from the voids is termed as primary consolidation or primary compression or primary time effect. Define secondary consolidation. Even after the reduction of all excess hydrostatic pressure to zero, some compression of soil takes place at a very slow rate. This is known as secondary consolidation or secondary compression or secondary time effect. What is immediate settlement? The settlement which is caused by the elastic deformation of dry, moist, and saturated soils without any change in moisture content. Define the term stress path. A stress path is a curve or a straight line which is the locus of a series of stress points depicting the changes in stress in a test specimen or in a soil element in situ, during loading or unloading. What are the shear parameters of a soil? Cand are the shear parameters of a soil where cis known as apparent cohesion is known as angle of internal friction. Under what circumstances is Vane shear test used? Vane shear test is a quick test, used either in the laboratory or in the field, to determine the undrained shear strength of cohesive soil. The Vane shear test consists of 4 thin steel plates, called vanes, welded orthogonally to a steel rod. Mention the advantages of tri-axial shear test as compared to direct shear test. The shear tests under all the 3 drainage conditions can be performed with complete control. Precise measurements of the pore pressure and volume change during the test are possible. The stress distribution on the failure plane is uniform. The state of stress within the specimen during any stage of the test, as well as at failure, is completely determinate. What are the advantages of direct shear test? It is easy and quick test for sands and gravels. Large deformations can be achieved by reversing shear direction. This is useful for determining the residual strength of a soil. Large samples may be tested in large shear boxes. Small samples may give misleading results due to imperfections, fractures and fissures, or the lack of them. Samples may be sheared along predetermined planes. This is useful when the shear strengths along fissures or other selected planes are required. What are the disadvantages of direct shear test? Uniform deformations and stresses in the specimen. The stress-strain behavior cannot be determined. The estimated stresses may not be those acting on the shear plane. There is no means of estimating pore pressures, so effective stresses cannot be determined from undrained tests. Undrained strengths are unreliable because it is impossible to prevent localized drainage without high shearing rates. In practice, shear box tests are used to get quick and crude estimates of failure parameters. Name the test used to determine shear strength of soil in the field. Cone penetration test. Dynamic cone penetration test. Static cone penetration test. Vane shear test. What is shear strength equation? The shear strength of a soil is a basic geotechnical engineering parameter and is required for the analysis of foundations, earthwork, and slope stability problems. This is because of the nature of soil, which is composed of individual soil particles that slide, i.e., shear past each other, when the soil is loaded. The Coulomb's shear strength equation is given by equals, plus. Define the term principal planes. A principal plane is defined as the plane on which the stress is wholly normal on one. This does not carry shearing stress. From mechanics it is known that there exist three principal planes at any point in a stressed material. The normal stress acting on the principal plane is known as principal stresses. State Mohr's Coulomb theory. The Mohr's Coulomb theory of securing strength of a soil, first propounded by Coulomb, 1976, and later generalized by Mohr, is the most commonly used concept. The functional relationship between the normal stress on any plane and the shearing strength available on that plane was assumed to be linear by Coulomb. Thus the following is usually known as Coulomb's law, where equals H equals. Write the four laboratory methods of determining the shearing resistance. The shear resistance can be determined in the laboratory by the following four methods. Direct shear test, Tri-axial shear test, unconfined compression test, Vane shear test. What are the methods to determine shear strength? Direct shear test, Tri-axial shear test, unconfined compression test, Vane shear test, consolidated undrained test, drain test, undrained test or quick test. What are the factors affecting shear strength? Resistance due to interlocking of particle. Frictional resistance between the individual soil grains, which may be sliding friction, rolling friction. Adhesion between soil particle and cohesion. What do you mean by soil? These are composite soils having both C and F. These are also called cohesive frictional soil. Example: clayey sand, silty sand, sandy clay, etc. Classify soils based on shear strength. On the basis of shear strength, soil can be classified as cohesionless soils, purely cohesive soils, cohesive frictional soils, cohesionless soils. These soils derive the shear strength from intergranular friction. It has no cohesion, i.e. C equals 0. These soils are also called frictional soil. Example: sand and gravels. Purely cohesive soils. These are the soils which exhibit cohesion but the angle of shearing resistance F equals 0. These soils are also called Fu equals 0 soil. Example: saturated clays and silts under undrained conditions. Cohesive frictional soils. These are composite soils having both C and F. These are also called CF soil. Example: clayey sand, silty sand, sandy clay, etc. What are the factors that affect shear strength of cohesion-less soils? Shape of particles, gradation, confining pressure, deviator stress, vibration, repeated loading, and type of minerals are the factors that affect shear strength of cohesion-less soils. What are the factors that affect shear strength of cohesive soils? Structure of clay, clay content, drainage condition, rate of strain, repeated loading, confining pressure, plasticity index, disturbance are the factors that affect shear strength of cohesive soils. What is Mohr's circle? What are the characteristics of Mohr's circle? The co-ordinates of points on the circle represent the normal and shearing stress on inclined planes at a given point. This circle is known as Mohr's circle of stress, Mohr, 1870. The graphical method for the determination of stresses on a plane inclined to the principal stress is called Mohr's wide. The characteristics are: the maximum angle of obliquity SS max is obtained by drawing a tangent to the circle from the origin O. Shear stresses plane at right angle to each other are numerically equal but are of opposite signs. What do you know about undrained and drained test? In the undrained test, no drainage of water is permitted. Hence there is no dissipation of pore pressure during the entire test. In the drained test, drainage is permitted throughout the test during the application of both normal and shear stress. Define shear strength of soil. The shear strength of soil is the resistance to deformation by continuous shear displacement of soil particles or on masses upon the action of a shear stress. The failure conditions for a soil may be expressed in terms of limiting shear stress, called shear strength, or as a function of the principal stresses. What are the limitations of Coulomb's theory? It neglects the effect of the intermediate principal stress. It approximates the curved failure envelope by a straight line which may not give correct results. What is soil exploration? The field and laboratory studies carried out for obtaining the necessary information about the surface and subsurface features of the proposed area, including the position of the groundwater table, are termed as soil exploration or site investigation. What is the object of soil exploration? Determination of the nature of the deposits of soil. Determination of the depth and thickness of the various soil strata and their extent in the horizontal direction. The location of groundwater and fluctuations in GWT. Obtaining soil and rock samples from the various strata. The determination of the engineering properties of the soil and rock strata that affect the performance of the structure, and determination of the in-situ properties by performing field tests. State the need of soil exploration. To determine the basic properties of soil which affect the design and safety of structure, i.e. compressibility, strength, and hydrological conditions. To determine the extent and properties of the material to be used for construction. To determine the condition of groundwater. To analyze the causes of failure of existing works. What are the uses of soil exploration? To select type and depth of foundation for adjuvant structure. To determine the bearing capacity of the soil of the selected foundation. To investigate the safety of the existing structure. To establish groundwater level. What are the objectives of site exploration? The object of site exploration is to provide reliable, specific, and detailed information about the soil and groundwater conditions of the site which may be required for a safe and economic design and execution of the engineering work. What is the equivalent penetration resistance given by Terzaghi's and Peck? Equals 15 plus 1/2, 15. Where NE equals corrected value for overburden effect, N equals actual value of blows 46. Define chunk sample. Hand-carved samples can be obtained if the soil is exposed, as in a test pit, shaft, or tunnel. Hand-carved samples is also known as chunk samples. Define inside, outside clearance in sampling tube. The inside clearance allows the elastic expansion of the sample when it enters the sampling tube. It helps in reducing the frictional drag on the sample, and also helps to retain the core. For an undisturbed sample, the inside clearance should be between 0.5 to 3%. Equals 3 1 slash 1 times 100. Outside clearance facilitates the withdrawal of the sample from the ground. For reducing the driving force, the outside clearance should be as small as possible. Normally it lies between 0 to 2%. CO should not be more than Ci equals 2 4 slash 4 times 100. What are the guidelines in terms of inside clearance and outside clearance for obtaining undisturbed sample? For an undisturbed sample, the inside clearance should be 0.5 to 3%. The wall of the sample should be smooth and should be kept properly oiled. The outside clearance should be between 0 to 2%. How will you reduce the area ratio of a sampler? Generally, samples with area ratio less than 15% are said to be undisturbed. So area ratio is reduced by reducing the thickness of the cutting shoe. List the various parameters affecting the sampling disturbance. Area ratio. Inside clearance. Outside clearance. Inside wall friction. Design of non-return valve. Method of applying force. Thank you for watching. For now, please subscribe, like, share and do not forget to press bell icon.